The beginning of the mystery of cosmic origins has always been humanity's oldest question. For countless generations, people have gazed upward at the endless night sky with wonder and awe. Every civilization, from ancient stargazers to modern scientists, has asked questions that reach beyond imagination, beyond science, and even beyond time itself. Every star that sparkles, every faint shimmer of distant galaxies, has seemed to whisper the same silent riddle. Where did it all begin? How long has it truly existed? And most haunting of all, what is our place in this unfathomable cosmos? In the 20th century, science offered an answer so bold that it reshaped our understanding of everything. The Big Bang theory became the cornerstone of modern cosmology. It proposed that all of existence, space, time, matter, and energy, emerged from a single unimaginably dense point, a singularity, around 13.8 billion years ago. In one incomprehensible instant, the cosmos itself was born. For decades, this idea stood as a triumph of human intellect. It explained why galaxies are rushing apart, why the universe glows faintly with ancient radiation, and how stars and planets slowly came to be. It gave us a timeline, a cosmic clock, and a sense of beginning. Yet, as with every great idea in history, the Big Bang has faced challenges. New discoveries began to unsettle its firm foundations. In 2023, NASA's James Webb Space Telescope stunned astronomers across the globe. It revealed galaxies so ancient, so massive, and so fully formed that they seemed to exist before the universe itself should have allowed them. This was no small correction to the model. It was a revelation that shook astrophysics to its core. If these galaxies truly predate the Big Bang's accepted timeline, then our cosmic story may be incomplete. Perhaps we are missing key chapters, or worse, perhaps the theory itself is fundamentally flawed. But Webb's findings are not the only puzzle. Closer to home, just 200 light-years away in the constellation Lyra, lies one of the most perplexing objects ever discovered, HD 140283, better known as the Methuselah star. To the naked eye, it appears ordinary, a faint, unremarkable dot in the sky. Yet, hidden within its light is a story that could rewrite cosmic history. Early measurements suggested this star was 16 billion years old, older than the universe itself. Later refinements lowered the estimate to 14.46 billion years. Even so, with a margin of error of nearly 800 million years, the paradox remains. How can a star be older than the universe that contains it? Determining the age of a star is no simple task. Unlike humans, stars carry no birth certificates. Astronomers must read subtle clues: a star's brightness, its color, its chemical fingerprint, and even the speed at which it spins. Over billions of years, stars gradually lose their rotation. This slowdown provides a method, called gyrochronology, that scientists use to estimate stellar age. But even with these clever techniques, the uncertainties are enormous. And so Methuselah remains a paradox, one of the oldest known stars in existence, and a challenge to our most basic assumption: that the universe cannot be younger than the stars it holds. Could our methods be flawed? Or is the cosmos itself far older than we have ever dared to imagine? To grasp the enormity of this puzzle, imagine compressing all of cosmic history into a single calendar year. The Big Bang erupts at midnight on January 1st. Galaxies swirl into form by spring. The Earth emerges in the final week of December. And all of human history unfolds in the last fleeting seconds before midnight on December 31st. On such a calendar, even a billion years of error is not a small miscalculation. It is monumental, enough to reshape the entire story of creation. Challenging the cosmic clock. Our current estimate, 13.8 billion years, comes from measuring the faint light of distant galaxies. As the universe expands, this light stretches into longer, redder wavelengths, a phenomenon known as redshift. By combining these redshifts with the Hubble constant, scientists arrived at the age we now accept. But bold new ideas are now emerging to challenge that number. Physicist Rajendra Gupta of the University of Ottawa has proposed something extraordinary. According to his research, the universe may not be 13.8 billion years old at all. It might, in fact, be closer to 26.7 billion years, nearly twice as old as we believed. To explain this, Gupta revived an older concept from 1929 called tired light. This idea, first suggested by Swiss astronomer Fritz Zwicky, argues that light itself could lose energy as it travels across unimaginable distances. If true, then redshift is not caused only by expanding space, but by the gradual fatigue of light. If both factors are at play, then our cosmic clock has been misreading time for over a century. This reinterpretation could solve the riddle of Methuselah and explain why James Webb sees galaxies that appear impossibly ancient. It would not be the first time humanity has rewritten its cosmic calendar. In the 1920s, Edwin Hubble estimated the universe to be just 2 billion years old. We now know this was far too short. Gradually, corrections raised that figure to 13.8 billion. Perhaps this, too, is only a stepping stone toward the real number, a far older universe than we dared imagine. Meanwhile, new insights into our own Milky Way deepen the mystery. The European Space Agency's Gaia spacecraft, mapping nearly 2 billion stars, found that stars on the galaxy's rim move more slowly than expected. This throws serious doubt on our understanding of dark matter, the invisible substance believed to make up most of the universe's mass. If galaxies contain less dark matter than we thought, or if dark matter behaves in ways we cannot yet predict, then the very architecture of the cosmos must be rewritten. For decades, dark matter has been treated as the unseen glue binding galaxies together. But what if it is weaker than assumed, or perhaps does not exist at all? The consequences would ripple across physics, forcing us to rethink gravity, structure, and even the birth of stars. At the center of these unfolding revelations stands the James Webb Space Telescope. With its golden mirrors and unmatched sensitivity, Webb peers into the deepest past. It has already shown us galaxies too advanced for their age. It is probing exoplanet atmospheres for the chemical traces of life. And it is testing the nature of dark energy, the mysterious force accelerating the expansion of the universe. Each new observation brings us closer to a crossroads. Do the laws of physics as we know them truly apply across all of space and time? Or are there hidden mechanisms, unseen forces, waiting to be discovered? Perhaps the universe is far older than we believe. Perhaps cycles of creation and destruction occurred long before the Big Bang. Or perhaps our tools and minds are still too limited to grasp the complete picture. One truth is undeniable. Humanity stands at the edge of a new era of discovery. The coming decades may transform our understanding of time, space, and even life itself. The detection of something as small as microbial life on another world would shake science, philosophy, and religion to their core. It would redefine humanity's place in the cosmos forever. For now, the universe keeps its deepest secrets. But curiosity drives us onward. The cosmos has only begun to tell its story, and the greatest discoveries still lie ahead, waiting to be found.